we look at the solutions to problem set 24 here, which are on the stem and leaf plot, one of our bankers. What does the key mean for a stem and leaf plot? Give an example. Well, the key is something like 1 bar 2 is 12 meters. So this tells us how to interpret what the numbers to the right of the stem are. We could also have 12 meters 2 bar 1 when talking about numbers to the left of the stem. If say that the key is 1 bar 5, 15 kg, what does that mean? Well, that means that the numbers to the right of the stem are digits after 1, and that the units are kg. So we are talking about weights. If we had 1.5 means 1.5 kg, then the numbers to the right of the stem would be in units of 0.1 kg. For question 2, we have 2 sets of data. Quite a lot of numbers. We use a back-to-back stem leaf plot to compare them, which can be done pretty quickly. So we begin by saying what the key is. So key 3.1 means 13 for the left leaves or leaves, and key 1.5 means 15 for the right leaves or leaves. So then we just have the stem and the 2 leaves. The one on the left is data 2 and the one on the right is data 1. This is a slightly different stem leaf plot in that we don't have 1.5, 1.6, 1.7. Each of the stems covers 5 decimal places. So this one would be anything beginning with 0, or the first decimal place being 0, so 0.0 up to 0.5. So we put any number which falls in that range here. So every time we get a number which is between 0.0 and 0.5, we put it here. So we have 0.1, that belongs there. Then we have 0.4, that belongs there. And you can see that we've got 1, 4. 0 is a bit unclear here. I mean, should it be here or here? Fortunately, we have an even number, so I've actually put 1 here and 1 here. So each of these has 5 numbers, so -1 up to but less than -1.5 goes up here, -1.5 up to but not including 2 goes here, and so on. So once we know our catchment area, in effect what the rules are, we can rapidly fill them in. So we go, okay, this is data 1 on the right hand side. So I go, is there anything which is equal to 2 which is greater than 2 but less than 2.5. Scan through, no. So that's blank. Here I want 1.5 up to but less than 2. So anything in that bucket goes here. So I start here. That's minus 1.6. I thought that might fit in. 1.9. So I add a 9. Keep looking. 1.7. So I add a 7. 1.5. So I add a 5. Another 1.5. I add a 5. 1.8, 1.5. So I add an 8 and a 5. So we pretty quickly fill this up. It's autopilot work. It's not complex. And then we do the same for the left. So now, once we've done that, we've created our back-to-back stem leaf plot. So now we compare them. It's actually not that clear what's different. The range is okay. This does go on the left. It does go up to 2.5. On the right, it doesn't even reach 2. It goes all the way down to minus 2. But this goes slightly more. So yes, the range is slightly larger on the left, but it is random, so it's not hugely different. That's the peak on the left is in the middle, while the right is kind of flatter, but not hugely so. Here there's not much at the tail, so more than or less than minus 0.5, there's only 1, 2, 3, 4, 5 entries, while here there's maybe treble that. So you could talk about the interquartile range. The interquartile range is probably, it looks like it'll be bigger on the right hand side. But that's really all I can extract looking at these. Actually, the right hand side was generated using a uniform distribution. So it's actually generating random numbers from minus 2 to 2, which were uniformly distributed. While the left hand side was generated using a normal distribution. So you'd expect the peak to be at the middle, and then you'd expect it to be symmetric. But bizarrely, there's quite a peak between 1.5 and 2. And that's the thing with random numbers. On average, if you ran it for many times, you'd get that clearer normal distribution. But when we're working with stem leaf plots, we're going to be working with data maybe up to about this size. More than that is hassle. So the main thing is do a couple of stem leaf plots. As you can see, I mean, it's quite mundane. It's quite you could do the operations when you finish primary school probably. So there's nothing to be stuck on or to be worried about. So do a couple of them. There might be some problems, mistakes when you begin. You can ask questions underneath the video on the YouTube channel or on the Facebook channel. Sort it out, because, as I've said, this is a banker question. The last while, every year, a question comes up and they just give you some data and ask you to produce a stem leaf plot. It might be just a stem leaf plot, it might be an ordered stem leaf plot, or it might be a back-to-back stem leaf plot. They're all equally easy. So once you know you can do that, then you pretty much know you've got guaranteed marks. Remember to subscribe to be updated when new content is added. Thanks.